Okay, so here's my catchy title. This is as good as it gets. It's all downhill. Yeah.
Love it.
Great. So I'm going to talk a little bit about, we can probably go to the next slide to the agenda. I'm going to talk about what is a deep energy retrofit for a building? What does that look like? And then talk a little bit about the case for a deep energy retrofit. So you heard from Mark about upgrading mechanical systems, and I'm going to talk about pairing mechanical systems and solar with envelope upgrades. So the part that keeps the outside out, the inside in, how can we help retrofit that to have a building that's much more efficient and as well as comfortable, durable, and healthy. So talk about that. I came up with 3 archetypes for church buildings, which you'll have to humor me on. And some of the positive impacts, I think we've heard a lot of that already, so I won't dwell on that too much. And then finally, a brief outro about reasons for hope. So yeah, go for it, Russell. Okay, so to start, a bit about myself. I am, as of September 1st, a proud co-owner of Airtight Engineering, which is a Saskatchewan-based consulting firm that focuses on high-performance buildings. So we do mechanical design for passive house buildings. We would also work on retrofit design as well. And that's sort of our niche. So it's myself, and then my 2 colleagues are both based close to Saskatoon. So we started out life as Bright Buildings, maybe 2013-ish. And the presentation from Michael Towers about Souls Harbor Rescue Mission, Bright Buildings was the company that did the mechanical design and the energy modeling for that. So it's a space that I'm very interested in and passionate about. I actually spent 5 years working for the gas utility, Sask Energy, with happened to be with Fred, and I left not because of Fred had already left, but because I felt a call in my heart to be part of the leading edge of climate change, and Sask Energy is making steps, but not the same steps that I wanted to make, and so here I am. I'm a certified passive house consultant, which is a great title, and I'll talk about what passive house means in a couple slides. I'm also a Christian who cares deeply about creation. I have for a long time. I don't know where that comes from, probably from falling in love with nature and obviously the tug of the Holy Spirit in my own heart. In my free time, I love hiking and camping, singing in choirs, and then gardening with my wife. We have a large garden close to Indian Head, and there's a picture of our squash harvest. Actually, that's half of our squash harvest from 3 weeks ago. So we love gardening.
Delicious, by the way.
Good, yeah.
The Russian garlic, A+.
Okay, yeah. Tasha's we don't actually pay her, but she does promote our produce like no one else. All right, yeah. Okay, so let's start with a few terms. What do we mean when we say a deep energy retrofit? So a great way to define a term is to let you know that there's no agreed upon definition for a deep energy retrofit. But in general, we're talking about a whole building overhaul that's going to reduce our energy use by kind of 50% plus. So we're not just changing light bulbs and recycling anymore. We're going to that kind of next level of how could our building be born again as a building that's ready for a low carbon future. So it may include measures such as window replacements, adding insulation, new heating system, adding solar panels, all of those big things. And we're going to have a strong project plan at the outset so that all of those can work together well to create a comfortable, safe, healthy, and low energy building. We don't want to accidentally make problems by saying, okay, we're going to do 10 different things, but none of those things talk to each other. And then we end up with, say, an airtight building that doesn't have any ventilation for the people inside. So very important that deep energy retrofit is sort of a whole building endeavor. Okay, now I'm ready for you. Another term, net zero. We've talked about this a lot. So often people are referring to net zero energy. So something that's producing as much energy as it's consuming. Usually we'll kind of do this on average over a year. So if you've got solar panels, you'd be producing more energy in the summer and less in the winter. And so if we just average over the year, how are things going. It can also be used for greenhouse gases, and that's also always often called net zero carbon. So are we sort of sequestering as much greenhouse gas as we are creating? That one's harder to achieve, but that's the sort of net zero concept. I have had people ask, okay, net zero, shouldn't we just aim for actual zero? I think that actual zero would mean we all have to stop breathing and stop moving and stop eating, which we don't want to do, right? So it's that idea, that kind of ecosystem idea of there are producers and consumers, and we work together. And so we get to have buildings that generate energy and then also consume energy, and hopefully that ecosystem works together. A little last note, we can also co-opt the term net zero, just like we can co-opt, the term organic or any of these other, you've got fair trade, and then you've got fairly traded, which is fair trade without any regulation behind it. So we need to be careful that we're exercising wisdom and not just looking for a sticker that says, hey, this is net zero, right? But can we really have intention, wisdom behind our desire to do right by the environment? All right. Okay, so net zero and deep energy retrofits. Just an example of what a deep energy retrofit is and how that might interact with that term net zero. So here's option one. To get to net zero, we could just do a ton of solar panels. And I'm not saying this is a bad thing. One of the challenges here is if we start to try to displace our heating load with solar panels, right? Because our electricity use is one thing for lights and sound systems, et cetera. But then our heating right now in Saskatchewan is mostly natural gas. And it turns out that energy from natural gas for heating our buildings is super high. And so in order to displace that with solar panels, your church building might look like this. It's just covered in solar panels. And maybe you would need a few kind of football fields on the side of solar panels. Some of the challenges with this approach, depending on the building that you have, are you might not have enough space on your building for all the solar panels you would need. Could be cost prohibitive. It's going to be hard on the grid if you're trying to heat with just electricity, because your solar panels would be generating lots in the summer, but then you're consuming lots in the winter. So how does the provincial electricity grid deal with that, right? It's challenging to store that amount of energy over 6 months. Also, depending on your building, if it's older and it was cold and drafty to begin with, it's still going to be cold and drafty. It's going to be green, but still not very comfortable. And you won't be particularly resilient to power outages, right? So if you have a power failure, that building is going to get cold very fast. Okay, option two. We could put in a new heating system and then solar panels. So here we've got our heat pump. So we've got a more efficient heating system. As Mark was talking about, heat pumps in Saskatchewan are maybe 200% efficient on average over the year for heating, whereas electric resistance would be 100% efficient, so twice as efficient. Okay, so this is better. We still need lots of solar. We might not have enough space on the building if we're trying to heat with solar as well, but it's going to be somewhat better for its impact on the energy grid. We're going to have improved heating and cooling capabilities. However, we are still going to need large equipment, right? Because I'm thinking of my own church, which is over 100 years old and uses a ton of energy to heat. We have no cooling system, so it just gets really hot in the summer. And the size of heat pump that we would need to heat and cool that building would just be insane. Like, it'd be very large. So now option three, we've got the deep energy retrofit option to get to net zero. So in this case, we're going to do an envelope upgrade. So the envelope is that kind of outside part of the shell of the building. We're going to improve its insulation, improve its windows, air tightness. Then we'll add a better heating and cooling system, and then we'll add solar. So the great thing about this is we only need a modest amount of solar now. Likely we're going to have enough space on our building for those solar panels, or a good chunk of them. It's going to be very energy grid friendly because we don't have a huge demand for heat in the middle of winter. It's going to be much more comfortable. So the great thing about an energy efficient or a deep retrofit is we get to improve the comfort and the health of our building, because what was once drafty, poorly insulated is now usable space that's comfortable all year round. It's also quite resilient to power outages. And I'll give you an example. So our company did have office space pre-pandemic in a passive house in Saskatoon. And there was one February, it was the first February that this building had been built and was opened. And the heat pump, which was the main heating system, wasn't working yet. And it was February in Saskatchewan. And it turns out that they were fine in the office space because they had 3 people and 3 computers, and that was enough to heat the whole building that they ran. So, so it was very resilient. They lasted, I think it was like a month without the heat pump, and it was fine. So an example of what we can do with a well-insulated building. Okay, so introducing, I talked about that example, this idea of passive house design. So this is, we've got 3 terms now to juggle in our heads: net zero, which is sort of a target. We've got a deep energy retrofit, which is a way to get to that target. And I would say passive house is a set of design principles to do a deep energy retrofit. So that hopefully captures those 3 terms for you. So passive house is really, it's a mistranslation of the German passive Haus, which probably is better translated as passive building. It doesn't have to be a house, but it just really looks like house in German. So, and so it's a science-based set of design principles to accomplish a deep energy retrofit. One sort of, I guess the kind of driving force is that it's an envelope first approach. So we're going to start with the building shell. We're going to start with your winter jacket, if you will, before we do anything else, and make sure that the winter jacket is good, the shell of the building is good, and then we'll move on to heating and cooling system and solar panels. And one of the goals is energy efficiency, but we're also looking at durability, health, comfort, resilience, all of these as well when we're doing a passive house project. Okay, I'm ready, good. So passive house, there's an international institute in Germany for the passive house standard. And there is a standard that you can build to, similar to, if you're familiar with R2000, or you can actually get like a net zero certification. So it'd be similar to that, or Chris is mentioning LEED as well as another one. Interestingly, 30 years after its creation, so it's been around since 1992, 30 years later, the passive house standard is still the most stringent energy efficiency standard in the world. To give you a sense of how stringent it is, if I had a 1,000 square foot house in Saskatchewan and it was built to the passive house standard, I could heat it on the coldest day of the year with a hairdryer, which is kind of insane, given that most of our furnaces would be, you know, like, I don't know, 20 hair dryers or something. A lot of, maybe not 20, maybe 10 hair dryers, but a lot of hair dryers. So you can certify the project according to the standard, get a fancy plaque. The other thing you can do is just utilize the design principles. And so that's what many projects choose to do as well. There's also a retrofit portion of the standard called Interfit. And so they've sort of developed a specific path for buildings that already exist that want to do a deep energy retrofit. Okay. Interestingly, the passive house design principles and standard have a very strong Saskatchewan connection. In 1997, in Regina, this house was built. It's called the Saskatchewan Conservation House. It's up, I think it's on like Rink Avenue or something. I've driven by it, and it looks pretty much the same, only it doesn't have the evacuated tube solar collector on the front there. It was designed by a couple of engineers, Harold Orr and Rob Dumont, among others. And this was kind of the first of, I've heard of projects in the States that are similar, but one of the first of its kind in the world. And they were saying, can we build a house in this climate that doesn't need a furnace, that just uses passive solar energy coming through the windows and is well insulated enough to stay warm. And largely, they're successful. They also invented technologies that are now used in efficient buildings. So they invented the first heat recovery ventilator, or HRV, which is a component that's used all over the world now for ventilation in efficient buildings, and the first blower door test, which is a way of seeing how airtight a building is. So we did all of this in the 70s, right here in Saskatchewan, and then we kind of forgot about it in the 80s. Energy was cheap, the government changed, they scrapped the project and sold it. A family bought it, they thought it was weird, so they put a furnace in it, even though it didn't need a furnace. So, that's what we do. And then the Germans in the 90s saw all these reports and all this data, and they brushed it off and said, wow, this is great. Let's make a standard that's internationally recognized and sell it back to Canada. No, so that's the Passivhaus standard. History of the nation.
Cool.
So yeah, kind of a fun Saskatchewan connection. So the Passivhaus design principles, I will try not to bore you too much, but they're pretty simple. There's 5 of them. And there's obviously kind of a body of practice that has developed around these core principles, but the core principles are straightforward. The first one is super insulation. So we should not insulate a building in Saskatchewan the same amount as somebody insulates a building in BC or California or New Mexico, right? We should have more insulation here. So you heard from Michael Towers about Souls Harbor. They have a 2-foot thick wall. You might think that's crazy, but why not? Why not, right? We're so used to having insulation just between the studs. Does anyone hear a dog barking? Yeah. Okay, second is airtight construction. So airtightness is something that in the past, we built buildings that were not very airtight. So they had a lot of leakage. They would feel drafty. If it was windy out, the building would be cold. And they relied for fresh air on those leaks. In modern, highly efficient buildings, we have a ventilation system that provides our fresh air. And then we make sure we've sealed the building so that we aren't getting air through all the gaps and cracks. Because really, I don't know about you, but the last time I checked the inside of my walls to see how clean they were was never. And so I don't want all of my fresh air leaking through those walls because chances are it's going to degrade the quality of the air that I'm receiving. So we want airtight construction. Third, high performance glazing. So glazing would be windows or skylights or glass doors. So we want to make sure we've got, at the very least, triple pane, argon filled, all of those catchy window phrases that you hear. But we want high performance windows because windows are they're the Achilles heel of our buildings. You think about, you have a big thick wall, then you have a window that's tiny and it's made of glass. And so, and they open and leak air. And so it's really important that our windows are high quality so they can let light and heat in, but keep the heat that's inside from leaving. Fourth, we look for thermal bridge free details. So a thermal bridge is anywhere where you have a spot where the insulation is broken. So there's no insulation, or maybe the insulation gets really thin for a location. So a classic example of this is if you ever see an apartment building and it's got all those concrete balconies sticking out, chances are that's just a piece of concrete that goes from outside all the way inside and there's no insulation. And so if you stand on the floor right beside that balcony inside the house, it's going to be just as cold as if you're standing on the balcony outside of the house. So that's a classic example of a place traditionally where we did a very poor job as designers and builders of having thermal bridge free details. And then the final thing is heat recovery ventilation. So we talked about air tightness and how we need to provide ventilation so that people can still breathe and be comfortable and healthy. So we use something, an HRV that was invented in Saskatchewan in the mid 70s. And what it does is it takes the air that's the sort of stale air out, it brings fresh air in, and it's able to take the heat from the stale air that we spent all this energy heating up and transfer it to the new fresh air so that we don't just waste all that 20-degree air into the -30 winter. So heat recovery ventilation is also a big component. So those 5 principles together make up the basis of a passive design. And I like this cartoon. This is our 19th century house. This is our efficient house in the 19th century. It's basically a house with a wood stove that's heating it. And then in the 20th century, we said, oh, we can do better than that. Let's do efficient housing. And it became really complicated. We had all these fancy doodads and lots of intricate mechanical systems. And the 21st century, we're moving towards more of a passive design where we say, hey, instead of having fancy mechanical systems, why don't we just insulate it more, orient the windows well, and make it airtight? So we'll start with that. And then we need quite a simple mechanical system. Okay, so I came up with 3 archetypes for church buildings in terms of deep energy retrofits. And I'm no expert in this. I just made these up because I like groups of 3 and the Trinity. So my goal here is to provoke conversation about perhaps what archetype your church building falls into, rather than to claim I'm an expert in church retrofits and how these archetypes should work. Okay, so type 1, we've got the Methuselah here. So this would be churches that are, reaching 100 years in Saskatchewan. If you're in Europe, they would probably laugh at that. It would be more churches reaching 1,000 years. But here in Saskatchewan, if your church is 100 years old, there's probably heritage considerations. So the church that I go to, Holy Rosary, we can't necessarily just put insulation on the outside because it's a heritage building, right? So you've got some of those considerations. You may have materials and methods used that were much different than today's practices, and that could cause challenges when you're designing a project. So Michael was mentioning spending 1.5 years in the design process and then 1 year building. You would definitely want to be doing that on the Methuselahs because you don't want to make a problem worse unintentionally. And may get uncomfortable quickly. I was trying to go for buildings that are very drafty. Perhaps I know in my church there are rooms that are really hot, right beside rooms that are really cold. It doesn't matter what time of year, and so often they aren't that comfortable to be in. So these are just some of the characteristics of that group of church. So some of the challenges. Heritage concerns I mentioned. How do we insulate a wall if the outside is beautiful brickwork and the inside's beautiful plaster? I don't know. I don't have the answer, but these are some of the things we need to think about. We've got material concerns. So often on some of those buildings that were designed without any insulation, those bricks on the outside of the building rely on all of the heat coming through the wall to keep them warm and dry. And if you insulate the inside of that wall, the bricks will actually start to deteriorate. So there are thankfully building science firms that specialize in this and can help us kind of guide us through some of those challenges. Another challenge is that some of those old buildings may have a large amount of repair work and other upgrades that need to happen before we can even get to energy retrofits, right? So a few challenges that came to mind for me, and I'm sure you guys are starting to chew and think on some challenges as well. Okay, so opportunities. First of all, there are a lot of these churches all over the world. Europe, I've found some great resources. There's some very good kind of academic studies that are happening in Europe around churches that are way older than our old buildings here. So churches that are built with just like solid stone. There's no insulation, there was no heating system originally, or plumbing or electrical system. So how do you retrofit that type of building? So we do have a lot of good resource in our friends in Europe. Another good thing is because we have all this other restoration work to do, we have an opportunity to pair it with energy upgrade work. So can we do them both at the same time and actually mesh together project costs, maybe even fundraising campaigns and that type of thing. Also, we get that opportunity to bring life to these unused spaces. Again, thinking of my own church, we have meeting rooms that no one uses because they're not very comfortable. But if we had the ability to do an energy efficient retrofit to that church and make it a more comfortable space as well as a more efficient space, we could breathe new life into it. Finally, that heritage value can be a challenge when we're planning a retrofit. It can also help drive the proposal for a retrofit. We can say, hey, instead of just knocking this building down or letting it degrade further, let's work at making it good for the next 100 years. Okay, type number 2. We've got the boomer. I'm going to tread very carefully on this age group. This is not in any way derogatory. This is just also when I typed in boomer on Unsplash, my free image resource, this is the guy who came up. So this is the boomer right here. Handkerchiefs, is that a thing? I don't know. But what I was thinking of here is churches that still have a lot of life left to give, right? They've got a lot of vigor yet, but they might have some assemblies that are starting to break down a little bit, or perhaps need more care, need more maintenance and attention. Generally, they're built with modern methods, but sometimes they're not outfitted with the latest technology. I don't know if that's the boomers of the churches, but so this is a different class of buildings, right? We might not have heritage considerations, but we might have maintenance considerations or stuff that's still not up to code, that type of thing. So a few challenges. They may be very inefficient still. We often, even buildings we build today can be very inefficient. So we can have a church that's 40 years old, might not have the same heritage value as our 100-year-old building, but it might be close to the same efficiency as the 100-year-old building, depending on how it was constructed. So that can make a challenge for us when we're looking to do an energy retrofit. In general, some of these types of buildings, it could be easier to start with a component by component plan. So maybe we come up with a whole retrofit plan, and it's harder to make the case for doing it all at once. Now, this introduces some tension between being fiscally responsible and also addressing climate change, which is happening fairly rapidly at this point. Some opportunities on these buildings, on the other hand, we do have a great opportunity for staged retrofits because chances are there are components that are reaching end of life. So maybe we have windows that are 50 years old. They need to be replaced anyways. So what a great opportunity to just bump up the efficiency of the new windows we're purchasing. So that's a great opportunity that I see with this age group of church. As well, often we can catch these buildings before significant maintenance arises. So, you don't have to deal with necessarily the fact that part of the building is divorcing the other part of the building, and you have to somehow join them back together, right? So that's kind of helpful. And the other nice thing is we can do more with the envelope than we can with the heritage building. So we do have the opportunity to add insulation to the outside. And finally, the youth group. So I'm saying kind of, 30 years old and younger, but we're in church circles. So really 40 years is, you could still be in the youth group, right?
My niece just got a membership in a golf course near Penticton.
Yeah.
And youth memberships are for $45.
Oh my goodness. That's amazing. Yeah. That's awesome. Yeah. So it's right on par.
On par.
On par. I didn't even notice. Oh my goodness. Thanks for the shout out, Tasha. Great. So these buildings, they might be looking really good. They're dressed to the nines. They've got all the latest gadgets, but they still might not be reaching their full potential. They might have been built as code minimum buildings, right? So they look brand new. They've got all the fancy sensors and touchless paper towel dispensers, but they still might be underperforming. They might just be, the sort of quintessential, whatever generation we're on, Gen Z or Gen AA, of youth who are maybe a little too much onto their phones. And I say this with greatest compassion because I spend too much on my phone too. But those buildings might be letting their potential as a brand new building pass them by. Okay. So some of the challenges, how do we justify replacing components on a new building, right? What if we have a building that's built to the minimum code, and now all of a sudden we have a new vision to retrofit it to a higher standard, and you have brand new siding on that building? That's challenging, right? That's tough to, yeah, definitely. A church like Resurrection, yeah, that's a good one. So yeah, upgrading without damaging all of these components that are still at the start of their useful life. Also, congregations, are they going to be willing and even interested in thinking about capital upgrades if they've just shelled out for a new building 10 years previous or 20 years previous? As well, we don't necessarily have some of the same drivers when it comes to comfort and functionality. So again, thinking of my church, there's a lot of space that's not even functional, let alone comfortable. And so we can add those as drivers to doing an energy efficiency upgrade. If you have a brand new building that's reasonably comfortable, all of a sudden that's harder to sell. So a few challenges with that group. Some of the opportunities is very few maintenance issues, right? So you can just get right on those energy efficiency retrofits. Often you don't have to worry about kind of maintenance issues. They can be good candidates as well for staged retrofits. And the good thing is you've got lots of lead time, right? There's nothing that's no maintenance issue that's necessarily driving, saying this component has to go first. So you can actually do the component first, which gives you the biggest bang for your buck in terms of energy. As well, some of these buildings might already have structures in place or be able to facilitate energy efficiency upgrades fairly easily. So they might have roofs that have enough capacity just already to add solar panels without having to do a full kind of structural rebuild of the roof, for example. Okay, so case study of the church that I go to, Holy Rosary. This is not this is sort of a case study in the works, because I'm part of a group of folks who are sort of a engineering focused working group to help develop scopes of work for a capital campaign for the church, which is ongoing. And we have millions and millions of dollars of structural, code, life safety, and accessibility issues that we need to deal with. Like, 6 to 10 million, like millions of dollars. And so, and it's a heritage building and it's over 100 years old. And so then we think about energy retrofits. How does that even make it onto the table when it's a struggle to come up with the capital campaign money to deal with even a quarter of all of those other things, right? I don't know the answer to this. This is a hard question. We scoped some packages that involved additional insulation while we were in a certain area of the building, and none of those have made it onto the top priority list yet because we have bigger priorities, right? We need to make sure that people in wheelchairs can get into the building and out safely. We need to make sure we have enough washrooms to meet code. So this is something that I feel very keenly thinking about energy retrofits. It's easy for me to talk about, oh, the deep energy retrofit, the passive house, we could heat it with a hairdryer, right? And then you come to the reality of your particular church building. Maybe it's not a heritage building, but maybe it's a dwindling congregation, right? Maybe you've got a great building, but 10 people in it. How do you make that happen from an energy efficiency perspective? So that's something that I'm also thinking about and wrestling with. A couple things that give me hope. The first is that I think churches have a lot of power for impact beyond the building itself. So when I think of doing a deep retrofit on a church versus on my own personal house, that church has a ripple effect on all of the members of the congregation, right? So it can have an impact on the carbon emissions of that particular building, but also, similar to our, the message of Jesus, right? It gets to ripple outwards towards the margins as well. we get an opportunity as well to revitalize our church buildings in other ways too. This energy efficiency retrofit piece can help be a driver to invest in these, what are really assets to our community and kind of can be a gift to our community. And finally, what a great way to attract young people. As according to the church, still a young person. I can say that I'm attracted by people who are engaged with the climate debate.
Yeah.
That's why I'm here, right? I'm actually, I spend part of my time going to the cathedral and part of the time, my time with another congregation that is very engaged with the climate debate. That's where my heart is. So I can't speak for every single young person, but I know for myself, that's something that attracts me. As a modestly young person still. And something else that gives me hope is the message of the gospel, right? So Jesus tells us, do not be afraid over and over and over again. And I take solace in that. Sometimes my engineering brain says, it's too late, there's no hope. And I have to, sort of engage that faith part of my being that says, hey, sometimes the loaves and the fishes end up feeding everyone, and we just don't know how it happened. Also, I see such potential in our churches, in our faith tradition. We have a faith tradition of a guy who staked his life on love and selflessness and sacrifice. And so what a model for us to do the same. I know it's tempting to just go by the numbers and say, hey, does this make financial sense? Does it not make financial sense? Well, I guess our building is just going to be part of the problem instead of the solution. But what if we took a risk? Okay? What if we continued this good work of engaging with our congregations, even to the point of taking a risk on our church building? I don't know what that looks like. We need to discern the creative spirit for that. But I know that's something that I feel in my heart is taking risks to be part of something new, as opposed to clinging to what we used to have in the past. So those are some of the things that give me hope. And then finally, the Holy Spirit, the ability for that creative spirit to help guide us, to furnish us with new life, new ideas, and new ways of being. So I'm very hopeful. Thank you.
Thank you.
I say amen, brother.
Yeah.
Let's preach it. Yeah.
You
Yes.
gotta talk to the microphone.
Okay. Into this one, or
It's okay.
For the
No,
people
it's
on-
not. The people online need to hear you.
They need to hear you.
Man, but if you do all the envelope things, and you've done all the mechanical things, the heating and cooling and that stuff, what's the role then of solar?
Mhm.
What role is it?
Yeah, great question. So once you've done envelope and mechanical, I think the role of solar is still there to offset that remaining energy use. But you're right, it might be much smaller. And you might discern that it doesn't make sense on every building, right? So there might be, if you have a very efficient building that has poor roof orientation for solar, you might say, hey, I'm going to focus on envelope and mechanical, let someone else do solar and help offset that last little bit. Yeah, that's a great question. Oh yeah.
Just another comment on that. I mean, as the solar person here, but I would say that that is a dilemma I've felt as someone who cares about the planet, as well as because the life of a solar panel is not necessarily a clean thing, and sourcing and what you do afterwards. So anything what you're talking about where we can reduce the, we just don't move into green, I guess finding green technologies is the total answer, but reduction in what we're doing. So I agree. Yeah.
Question in the chat.
One question, Sean, hang on.
Where is the biggest bang for the buck? That is, if in a diocese we pool resources, which of the three types would be better to upgrade and have more efficiency per dollar spent?
Yeah, so I'm going to take the three areas you're thinking: mechanical, envelope, or solar, potentially. I've drunk the passive house Kool-Aid. And so my,
3 types of congregation.
oh, 3 types of, oh, sorry, okay, 3 types of building, I see. So the Methuselahs, the boomers, or the youth group, gotcha, okay. That's a tough one, that's a good question. I think that probably there's low-hanging fruit in each. I'm gonna say that likely starting with the boomers or the Methuselahs, because by and large, in theory, the youth groups should be performing better as a baseline, right? So we would see this similarly in residential retrofits, where there's an age of house where we say, hey, this is still pretty new, so let's not worry about it yet. Let's tackle the older houses. Having said that, there's probably a sort of a Methuselah age after which we say, this building's gone too long without upgrades and repairs. It's actually not worth doing an energy efficiency retrofit because, let's say, it's no longer structurally sound, for example. So there is probably a sweet spot kind of in that boomer age, and you don't have to deal with all the heritage considerations necessarily, depending on the building. So I think bang for your buck, that's probably a good place to start, would be my gut instinct. Yeah, any other? I just want to say one thing to Josh's point when he was talking about the solar panels. Interestingly, I've seen some studies where we talk about cost per kilowatt hour of energy. So something like solar, and we can compare that to wind and fossil fuels. We can also compare that to a kilowatt of energy saved by more insulation. And that kilowatt hour of energy saved always comes in at the cheapest. So it's amazing because you don't have those life cycle issues of that you necessarily have with, say, batteries or solar panels.
Yeah.
And it's actually the cheapest to just save the energy in the first place. I don't know if Jesus said waste not, want not, but it's probably there somewhere. Yeah, any other questions or even discussion?
So my question is, do you do presentations at, like, say, parish councils or board meetings or best for you? Or what kind of resources are available to help? Sometimes it seems like there's just a few crazy people out in the wilderness yelling about, climate change and the need to do retrofit. And it can be very difficult to get people on board, even start the conversation, right? It's so polarized. So do you have any, I guess, resources or ways to engage and to have start that healthy conversation for those of us who seem like crazy prophets out in the wilderness?
It's a great question. Well, I would say hearing about some of those other groups like Net Zero Churches is awesome. I quit my other job so that I could do stuff that's in this sphere more. So that's give me a call.
Okay.
Yeah, I'd say I enjoy talking in front of people and hopefully making them smile.
Yeah.
Or giving them a good time for sleep and contemplation. Either way. So, but yeah, if maybe that's a good thing for us to think about as a community. Can we come up with a group of people who are willing to help engage? I'm also thinking of Bill. I know that you like talking about this type of thing too, so could get you up here in front of a.
Yeah, Chad mentioned that.
Okay, some chat mentions good. Okay. Southern Sask has the best solar access in all of Canada. Our electrical costs were much higher than heating in our home. Doing solar first will help pay for the rest. It is really easy to implement compared to other upgrades. Yes, that's a good consideration for sure. Especially, yeah, solar is much more expensive than gas. So if you're heating with gas, often the solar gives you a faster payback. So that's a consideration. Mennonite Church Canada is trying to do just that. Newer churches are encouraged to contribute to retrofit older churches, but they haven't figured out where the sweet spot is. And new churches tend to have more higher income congregants. Yeah, that's interesting. I think about that in the city of Regina too. You know,
Yeah.
got some parishes that have a lot of income coming in, and then some that are older and have older congregations too. Mark, my question was based on if there are a couple of churches that want to become more energy efficient in a diocese, region, denomination, should the newer church maybe give money to the boomer church to upgrade because it will have more overall effect than the newer church upgrading itself? That's really interesting. That idea of how can we sort of maximize our impact by working together. That sounds kind of gospel right there.
That last question just sort of raised, but I mean, the last suggestion you raised the question for me, if there is in fact a structure, because just because churches belong to a diocese or something does not mean that they have a structure for sharing their funds, right? When I was in Saskatoon, the diocese there had a building development fund where congregations that had some extra funds available could put it on deposit with the diocese, and they got paid, you know, an interest rate. It was maybe not quite as good as they could get if they were getting GOC or something, whatever. But they were getting some money back, some interest rate on it. But parishes could also borrow from that fund at a very reduced rate, so much lower than getting a loan from the bank. And then the diocesan building committee would review all of those projects before they were allowed to be built. And it worked out quite well when their churches had money available. And eventually, all the money got, taken. They had to raise bank loans, so that the parishes had to pull their money out to use it on other things of the projects to the diocese. But having a structure for doing that kind of sharing of funds between parishes, it would be necessary to make that happen. And it could happen at community.
What a great idea, though, that sort of ecology and care for creation is an impetus for us all to share as Christian denominations and parishes. Any other questions or thoughts?
I found your presentation very helpful. Could you please comment about heat pumps? Because if you go to our plumbers in Regina, they'll reject the idea of heat pumps. They say they're no good in Saskatchewan. Can you comment about that and possibly how you connect heat pumps to solar energy, because of course the heat pumps are driven by electricity?
Yeah, thank you. Heat pumps are a problem when it gets very cold. And if you regularly spend a lot of time below -27, then you need some backup heat. That's for sure. And the question becomes, in a given location, should that be natural gas or should that be a radiant resistive heating from electricity, which takes you back down to the 1-for-1 output of energy. And so it's a bit of a challenge, but most of our time is not below -27. And so that means all of that other time can be heated with air source heat pumps or geothermal. So there are some considerations like that. But most of the plumbers who are fighting against it are people who are doing, I would suspect, doing pipe fitting for natural gas. So it's in their interest to fight against it, isn't it?
I could add to that as well, that Airtight Engineering has designed many buildings that are heated and cooled with heat pumps, some of which are in Saskatchewan and are successfully operating. So I can definitely give you examples of buildings that work with heat pumps. We still have trouble with clients as well. We'll design a system with a heat pump and that client will say, oh, take the heat pump out, it doesn't work. And we'll say, well, actually, our office was in a building that was heated with a heat pump and it worked. But yeah, that's a challenge for sure as it kind of gains adoption in Saskatchewan.
Can you give any examples of working churches or similar buildings, successful examples of heat pumps working in the West, in Saskatchewan?
Sure, I can. Okay, so we worked on the mechanical design for a community center in Cumberland House First Nation in Saskatchewan. So up kind of northeastern part of the province. I guess it's not really north, but central eastern part of Saskatchewan. And its first stage heating was a heat pump. And it's been successfully operating for 2 years now. So it has backup heat when it gets quite cold, but it would use a heat pump for all of the shoulder season heating and all of its cooling as well. As well in Saskatoon, Radiance Co-housing, which is a 9-unit sort of co-housing condo complex. It's heated with 2 heat pumps down to maybe -20, I think, or maybe 25. And then below that, it's got electric resistance. And it's been running since 2018 without any issues. So, and I could, yeah, those are 2 off the top of my head, but I definitely have more examples as well of projects in the province. One thing, some people were familiar with heat pumps 20 years ago, and 20 years ago, heat pumps could go down to maybe -5 or -10. And so, yeah, it was a challenge in Saskatchewan. Today's heat pumps can go down to -20, -25, -30. And so we actually see that they pair quite well with our climate and can carry the majority of the heating load. Yeah.
So for those weeks, it's -50.
Yeah, except the weeks that are -50. Yeah, exactly. But you know, electric resistance is pretty cheap to install, and if you're only running it, you know, those 2 weeks.
What is that?
Electric resistance, that would be like, think of, it's the same principle as if you get a little space heater, but it could just be delivered in different ways. So it could be an electric coil on the floor, could be an electric furnace, could be, yeah. So it could look a lot of different ways, but it's just heating up an electric wire. It's running current through a wire, it gets hot, and it heats up your room. So it's quite cheap to install because it's just wires. There's not much, there's no, you know, not much going on.
I have heard that one of the considerations for Saskatchewan is, can you pair heating with the cooling? Because then you get a lot of efficiency. You're basically for a ground for geothermal. You're basically using the ground as a heat battery while you're moving from cooling in the summer to heating in the winter. I've heard recently about dual source heat pumps that would then be air source on the shoulder season, and then they'd be using the summer cooling and the really cold temperature heating to balance each other out. Have you looked at those?
I haven't looked into those too much myself, but that's a good idea because that is one of the challenges with ground source is if you have, yeah, the ground is the battery. And if you're putting in all this heat over the summer and then taking it out over the winter, that works until you end up taking twice as much heat out in the winter as you put in the summer. And then the ground just slowly gets a little colder each year, maybe a degree, maybe 2. And then 10 years later, the ground is just kind of cold all the time and you lose that efficiency. So yeah, if you could have that dual source, I would say in principle, sounds really good. My one spidey sense that comes up is more complicated is not always better. But in principle, I like that idea. And I've heard of other ways to try to balance that heating and cooling for a ground source. Because yeah, that's a good point. Okay, we've got a comment in the chat here. The bottom one? Yeah. Okay, Ingrid says, some churches in Mennonite Church USA have self-imposed carbon offset donations. For example, best not to take a flying holiday, but if you do, a voluntary offset is paid to the carbon account to pay for a carbon reducing project. This works best if many churches are participating. That's a great idea. I love that. Yeah. And what a great way to help engage people with that common mission then as well. Thanks for sharing that.
Isn't that like that kind of stuff feels to me? That kind of thinking though also feels to me like some of the challenge around net zero.
Yeah.
In terms of like, I equivalent it to the history of buying indulgences. That we're paying something so that we can continue to sin.
Yeah, as Tasha was saying, what's wrong with indulgences? Yeah, I think to me, that's where that sort of, where really it's got to be about where our heart is at, as opposed to the sticker that we're putting on it, right? I think, for me, there are times when I'm going to fly, and even though I know there's a carbon cost to it. Let's say my sister in Toronto gets sick, I'm going to fly, but maybe I'm going to say, hey, I want to participate in this carbon offset program. If I'm saying, well, I wouldn't fly to Bahamas every year. Oh, but I could just pay this carbon offset. Great, I'll fly to Bahamas every year. Maybe that's the point at which, yeah, it's sort
Or
of.
governments allowing the fossil fuel industry to continue
Yes.
doing what it's doing by doing carbon offset.
Yes, yeah, exactly. The carbon offsets is the double-edged sword. Yes. No, I agree. And that's that whole, that knife's edge of how can we be truly making the difference that we're hoping to, as opposed to just doing a lot of fancy accounting. Yeah, that's a great comment.
Matt, thank you so much. This has been very eye-opening and really thoroughly enjoyed your presentation. I just want to be respectful of our time. So we will have a plenary at the very end where we can talk about maybe some steps that we want to take as a community to help support each other in continuing this work, and what resources and supports we might need. So I'm just putting a pin in this conversation for a little bit later. Really great stuff. Thank you so much, Matt.